Yeah, so introduction. So let's read the definition what we have for CTI. CTI is knowledge that helps understand malicious threat actors, their motivations, goal, targets, attack behavior. So CTI is more about collecting information, sharing that information, processing that information, and using that information to make sure that we are ready to defend against malicious threat actors. And the value of CTI increases upon in a timely manner. Suppose I have a CTI intel about threat actors that's going to target, suppose, say, an oil and natural gas industry. If I have it in time, then probably I'll be able to again information already taken place, then the value of that information goes down. So sharing CTI in a timely manner is very important, and also to consume that is as vital as sharing it in a timely manner. Then the one of the things that we see with CTI is the quality standards and parameters. Like if I give you 100 IOCs, but then out of that 100 IOCs, only 10 IOCs are relevant and valid. The other IOCs are probably like the cloud provider's IP or some IP for DNS, then that's not going to be very relevant for what I have in my organization. So it's very important that the quality of the shared intel are up to the standards in order to be effective. Then what is blockchain? Blockchain is pretty much a digital that's to everyone, yet it, well, I would say immutable, but very hard or probably impossible to change. So any transaction that I do on blockchain is always written into the chain. Suppose I write something on the chain and then I want to delete that from operation is another transaction. So anything that you do on blockchain is probably unmutable. Let's keep it at that. Then yeah, we'll talk about loyalty, which is the DApp that I'm going to present today. So that and data and CTI standards. So like how to use blockchain to store the CTI information. While storing the information, I'm just going to make sure that I'm not storing any IOC or Intel information, but only the IOC information or Intel satisfies my standards or my minimum required criteria to be in that blockchain. The data in this system becomes a trustworthy source of information which can help assess the reputation of the sources. Suppose I have 10 different sources giving me Intel information, and I just want to make sure that all my 10 sources are up to the standard, and I want to make sure that I trust those sources. So how do you build a trust mechanism, and how do you trust those sources just to make sure that you don't want to revalidate again and again, but then want to use that IOCs in your production right away? Zero knowledge proof. This is an amazing concept in blockchain that came out in the recent few years. So what this actually talks about is if I have a statement with me and I'm providing that statement to someone else, but then I don't really want to reveal the content of that statement, but at the same time, I would just want to prove that my true statement is valid. So how are you proving to someone a statement without revealing the contents of that statement? Suppose you have your national ID cards, but you don't really want to share sensitive information or your PII with someone, but you just want to make sure that the other person or the validator gets to know that you are the exact same person you're claiming to be. So that's zero knowledge proof, and we'll see how we are implementing zero knowledge proof in our application to make sure that we respect privacy and share intels and maintain the quality of those intels as well. Limitations of traditional CTI model or the current existing CTI models: inadequate threat actor understanding. I'd say that now not any model, or I'd say any model you can come up with, it's not going to be very up to date about the CTI information. I cannot predict what's going to happen in tomorrow. I can make assumptions, but I cannot give you for sure that, okay, this is what's going to happen tomorrow. Like I'm not FBI or NSA to give you 100% accuracy of this is going to happen tomorrow. So limited understanding of threat actors' behavior, motives, attack techniques hinders effective defense. So unless I know what's my threat actor looking like, what are the attack vectors that threat actor is going to use, and what are probably the areas or the attack surface where that attacker is going to focus on or exploit vulnerabilities. Unless I have a complete picture of my attacker, I might not be able to defend it efficiently, because you cannot provide a 100%. More important to understand the threat actors targeting your industry and accommodating your defenses according to that. Data overload and scattered information. As we know that we are just getting into a digital era of information, we have terabytes of data generated by an endpoints like in a day, and then the volume of that data, how are you going to process all of those volume of data? How are you going to take efficient, I'd say, valuable insights out of that data, and then use that for your threat analysis or your defense? So handling large amount of data is one of the problem that we have in like any industry, not CTI, but then if I talk about your normal cyber security operations, or I talk about artificial intelligence and data science, the problem exists anywhere. How are you going to tackle, or how are you going to process all of that data? Lack of timeliness, as I told again before, the importance of providing that threat intel information in a timely manner is very crucial for that to be effective. And limited quality assurance, I am not very sure if the information provided by my source, let it be in a format of sticks, taxi, or whatever, but then the source that I'm like receiving intels from, most of them are open source standards, and then I'm not very sure if the quality of that threat intel is what they say it is. uh, like there was this one incident, I'll just quote an incident. So we had supply chain KaiIyer supply chain incident, and then a lot of intels were like going around, and one of the very good intel sources, FBI intel sources, they were providing a lot of IOCs, and then one of the IOCs in there, like hundreds of IOCs, was 8.8.8.8, and the organizations who just plugged that in just had a like lot of alerts coming in, and their L1s and L2s were like, oh, this is way too much, we are not able to like handle all of this volume of alerts. So making sure that the quality of the intels that are being provided is up to the mark is very crucial when we deal with CTI. Lack of trust. Now, I'm an organization who has some intels. I recently dealt with an incident, either for myself or for maybe my client. But then, how am I gonna trust the community or trust the platform before sharing that intel? Are those intels being utilized properly? And like the trust mechanism is important, because you do not want to share information to someone who you do not trust. Inadequate incentives. Okay, I'm gonna give you some information, but what am I gonna get in return? I know open source community is very like giving, and then they don't expect anything in return. But at the end of the day, the intels or the crucial intels does have or does are with the organizations which are like in the private sector. And in private sector organizations or corporates, we talk about profit. What am I gonna get in return if I give you something? So it's not more about like sharing, but what am I gonna get in incentive if I share you intel? Then resource constraints. Small organizations or some organizations like startup or a small or medium organizations might not have a threat intel platform like a MISP or any other tool in which they can like put all of their IOCs, tag them properly, share it with the community or share it with the open source organization. So resource constraints is one of the problem. And one more problem, I mean, I've not mentioned it here, it's not very relevant, that's retaliation. Like I'm a CTI company, I'm like giving out very valuable information about a particular threat actor out in the open. What if that threat actor or some other threat actor is gonna target me and then come after me? That's retaliation, but not very relevant. Reluctance in sharing. Why am I not sharing CTI? What's the problem in sharing CTI? Data sensitivity and privacy concerns, right? So I'm an organization, I have got some compliances, like I cannot share client data, I cannot share some crucial data, because I have to comply with the policies that my organization has laid down, or some ISO certification saying that, okay, you are not allowed to share these amount of details in the out. So that's one of the reasons. And then competitive advantage. If I have got more information about the threat actor than my competitor, suppose I'm a service-based company, I'm providing an MSSP, and I'm going to a client and I'm saying that I can defend your organization better than my competitor because I know the threat actors better than them. So that's a competitive advantage. Why blockchain for CTI? What are we going to do with blockchain? So the problems that we have, which we discussed, is the demand for CTI is growing really fast. I was scattered. Like I know there are standards. We have like CTI sharing standards. Sticks format is there, taxi is there. But then are everyone following the like while sharing CTI? Are everyone following that standards? Are we having a proper, what you can say, standard or a common way of sharing CTI? Why share CTI intels without incentives? How can CTI be shared without compromising privacy, and quality of threat intel data can vary and often lacks quantifiable metrics. So these are the problems that we are going to solve with blockchain, because there are like 10, 20 problems that exist in the current CTI model, and we cannot solve all of those problems with blockchain. Blockchain is not a silver bullet solution to solving all of your problems, but some of those problems can be solved with blockchain, and we are going to see how we can solve these problems with blockchain. So the proposed solution is blockchain offering a comprehensive solution to the challenges in CTI sharing. Okay, now what are we going to do that? Ensuring data integrity. Like I've seen IOC in the wild, and I want to share it across. Now, the most important thing when sharing that is the timeliness. How do I know when was it seen for the very first time? So immutable timestamps is one thing which I really want with my IOCs. Utilizes a reputation mechanism to build trust within the CTI sharing community. How do I build trust and reputation? Like, I'm a source which is providing CTI information, but how do my consumer trust me? What is my reputation? How do I build that reputation and trust? Enforces quality standards for CTI feeds. Are my CTI feeds up to the mark or satisfying a certain quality? Then combines the 5 different factors which is very crucial for CTI: reliable sources, sufficient context, consistent data model, defined process, and automation. We'll talk about automation because at the end of the day, we are like moving towards an automated model, and we just want to make sure that how are we gonna chunk through a large amount of data, get intels out of it, share it with the community, and how can we scale it up? So scaling is very important when you want to do CTI for various organizations, but not just within your organization. So we'll be seeing how we can achieve all of these using the app called Lloydie. Just a flow chart of this. So this is a high level understanding of what we are going to see. So I have my source, which is the submitter. Suppose I'm a submitter or I'm a source. I have some intels. I'm just going to log into the portal or log into the app, and I submit my CTI or submit my intels. Now, after that, it's going to send that across to the validators. The validators are anyone who has some reputation in the like CTI community and can validate those sources. We'll talk about how are we gonna select the validators and how are they gonna score that intel. Then we have an intel quality evaluation, which is gonna take something called a proof of quality, proof of work, proof of stake, proof of value, different concepts in blockchain. So we'll see what is proof of quality and how is an intel evaluated against a proof of quality. And after evaluation, if the mean score given to that intel information is greater than the accepted score or the minimum required quality standard, that's going to be written to the blockchain. And then from blockchain, you take some information about the validator, because we also want to make sure that we are not using the same validators, but then we also want to make sure that are the validators good enough? Are there some validators who are just playing around, not giving the right amount of information? So validator information is also going to be extracted from blockchain, and that's going to be used to select validators for the next step. So that's an iteration. So this is the high level overview. And once those are in the chain, you literally can log into the portal like you are the consumer. You just want some IOCs, you log in and you extract those IOCs or intel information. The app role. So any app has got some functionality of the users that can log into that app or the users who can use that application. So we'll talk about 3 primary users. The first one is a submitter who can submit the intel information with an attribution and proof. So I have got some intel, I did some research, I did some incident response, I got some intel information. I want to share that. Now I have to share that along with the proof or the attribution saying that this is how I got this, because the proof is required for a validator to validate how you got that intel and is that the right intel that you want to share with the community. Validator evaluates the intel and assign a score if the mean score is greater than the score which is accepted, which is required for accepting it into the blockchain. It's going to be written into the block or else discarded. Then consumer. So the consumer is any user who just want to use CTI information can log into the application, see the first seen score, first seen date, sorry, So when was this Intel seen for the very first time? What's the score of this Intel, like out of 10 maybe? And then the tags. What is this Intel doing? Suppose this is associated with Cobalt Strike. This is associated with some ransomware group, or maybe this is associated with an brute force scanner, something of that sort. This smart contract and the validator selection. So when we talk about blockchain, it's always about the smart contracts and how is a smart contract gonna evaluate all of these things. So the first thing, the IOC will have the following features. The IOC will have an address of the submitter. This address is the blockchain wallet address of the submitter, because after submitting this IOC and this IOC is written into the chain, we also want to reward the user. So the incentive that I talked earlier, the user is going to get rewarded for all of the activities which is written into the chain. So how are you going to reward that user? So that's why we take the address of that user, then the IOC type, probably three types. It's an IP address, it's a domain, or the domain or a DNS query, and then you have hashes, SHA-256, MD5, whatever. Then a Boolean value for validated. Is this validated and written into the chain, which is true or else false? Then the quality parameters, we have some of the parameters which are required for that quality evaluation. So those parameters. So this is how a roughly structure of an IOC is going to look like in the blockchain smart contract. And then the selection of pool of validators. So the selection of validators is performed by something called a validator selection mechanism, also called as VSM. Then the initial validators. So I know how to select a validator if I have like hundreds of validators and I also know the reputation of that validators in my chain. But then how am I going to select the validators in the start? I mean, I don't know the validators' reputation or the trust. So how am I going to select my initial set of validators? That's basically based on the trustworthiness outside the chain network. That's like you are someone who has been working in the CTI industry for a few years and you have got some good reputation in the company and you have got some good reputation in your community. That's how we select the initial validator. But regardless of how you select your initial validators and who you select as your initial validator, once you have all of those validators in, the validator selection mechanism is going to just select the validators with the highest reputation. So it doesn't really matter who the initial validators are, because as we progress with the chain, the validators who gets in are the ones who actually have a reputation in the chain. Intel quality evaluation. Okay, how are we gonna evaluate the Intel quality? Suppose I have an IOC. What are the parameters against which I'm gonna evaluate that? First thing, false positives, frequency of feed invalidations. Suppose I'm saying that I had a ransomware incident recently, and this is an IOC. The attackers hosted the C2 on an Amazon EC2 instance in a like EC2 instance, and then I'm giving you a random Amazon IP. Is that valid? Is that for me to say that, okay, Amazon IP is a ransomware C2 host? No, that's not enough. So false positive or the tendency of that Intel to be a false positive. Verifiability, connection to the primary information sources. How good of an how can I evaluate that IOC, that this IOC actually came from this particular incident or from this particular what you can say tag, whatever tag, this particular question. So can I verify that? How easy is it for me to verify that? Then intelligence, added value through associations with other data. It's more like enriching that IOC with some additional information that you want to provide alongside that IOC. Suppose I say I have a file name, which is say WannaCry.txt, but is that an IOC? Uh, but then if I say that I have an MD5 hash of JavaScript, which is gonna encrypt all of the hosts in my network, and then providing that alongside the contents of that is gonna help me understand that, okay, this is something which is very relevant and I can add this to chain. Interoperability, adherence to specific data format standards. If the IOC or the submitted intents are in a given format, suppose it's sticks or taxi, then it's easy for me to put that in the chain. But if it's in a format which is not very easily understandable, I'm just going to give a CSV file, fine. But if I'm going to give you HTML file, it. You just have to extract that data out of it. Not that great. XML file, not that great. So the formatting, how you submit that, and how that format is aligned with the standards which you are using for your CTI model. Then syntax accuracy, feed compliance with standards. I mean, how accurate that is given to a particular syntax. Suppose I want to ingest all of these in a nested JSON format. How like how syntactically accurate that is? Is it following a key value pair? Is it just giving random values in a structure? How you actually submit that in a particular format. Originality, the uniqueness of your feed. Suppose someone has submitted an IOC 1 year back and you're trying to submit the same thing again. It's not your original thing. It's not unique to yourself. It has been submitted by someone else. So how original or how unique is your Intel information? Timeliness, how quickly you are releasing your Intel information. I had an incident with a client last month. I'm releasing it today. Well and good. I had an incident with a client 2 years back. I'm releasing an Intel today. Not that great. So how early or how fast you're releasing that Intel is also information. The impactness. Suppose I'm giving you an IOC, which is a brute force scanner. Now I'm giving you an IOC, which is a C2 that hosts your, suppose, say, GoodKit malware. So how impactful that is to an organization. Brute forces, port scanning, not that great. I mean, I'd give a score of like 2 or 3 because I don't really want to care about the open source scanners or the Nessus scanners, Quali scanners. But if I have something sort of hash of a script or an executable that has got some particular tactics, and then I just want to give that as an Intel, I'll probably value that more than my own like brute force scanners. Validators performance. Now we talk about how an Intel is going to be submitted to the app and what are the quality parameters on which that is going to be evaluated. Now I want to know how are the performance of a validator is going to be analyzed. So I have a couple of validators. Suppose say I have 10 validators and I have one IOC which is submitted, for instance. Now, how am I going to validate their performance? I just want to make sure that I'm not using the same validators again and again. I'm iterating over them. But how am I going to measure the performance of them? So after validators submit their scores, the very first IOC, suppose say A dot, suppose I'd say A. For an IOC A, there are 10 validators. They're submitting a score out of 10. Now, the first guy is going to submit, suppose say 3 out of 10, second guy 4 out of 10, 7 out of 10, 8 out of 10. 10 guys have submitted their score out of 10 for the IOC A. Now, I'm going to calculate the mean score of that IOC. Suppose the mean score is going to be 5 out of 10. Now, I'll calculate the deviation of each validator's rating from that mean, which is basically a root squared mean error and whatever you want to call it. So it's basically a standard deviation. Now, I'm a validator who has submitted 5 out of 5 and the mean came out to be 5 out of 5. Good enough. I'm a validator who submitted 1 out of 5. And then what is the deviation from that? So the more the deviation, the less your reputation is going to be. The closer the like the smaller the deviation, the closer you are to the mean. That means you are right on your money. Like suppose everyone has given it like a score of 9, mean comes out at 9. I'm just one random guy who's submitting like 2 out of 9. So I'm like deviating a lot from that mean score. So probably my reputation is not going to be that great for that particular IOC. Now, use this deviation to update the validator's reputation score. Use a voting procedure among the validators to finalize the status of each IOC. Now, I have 10 validators, and then I know that out of that 10 validators, I have 6 validators who have a high reputation. Those 6 validators are going to be final decision makers whether this IOC is going to be. If the satisfies the quality criteria, write it to block and update the chain. What happens after an Intel is published? So once the IOCs are on the chain, they become accessible to all the users for the intended use. Now I have a database of Intel information and any user can search the Intel information from that. The number of qualified IOCs will be used to provide rewards to the submitter. Suppose I'm a submitter who has submitted 10 IOCs and all of my 10 IOCs got accepted and are in chain. That means the IOCs that have submitted have got have met the minimum quality standards on the chain. Now it's time for me to get rewarded. And then the validator who's going to validate this IOC is also going to get rewarded, because why would I go and validate IOCs if I'm not getting rewarded in that? So the submitter is going to get rewarded, and the validator is also going to get rewarded. Initially, we'll distribute it something around 50-50%, and after that, we'll change it accordingly to a point where the validator is not existing in that chain, and that validation process is completely automated. Now, how are you going to automate the validators? Like validator performance thing and the validation thing, it's more or less like having random forest. Okay, a bit into random forest, you have a cluster of trees, and every single cluster is going to come up with some score, and then out of those, some trees are going to be selected to give you the final answer for that. And then clustering mechanism to see the reputation of those validators, and the cluster with the highest reputation is going to be selected, and the outliers are not going to be selected. That's how you choose your validators, and measuring their performances as well. The consumer, so I'm giving out rewards to my submitter and my validator, but where is this money going to come in from? So when I talk about money, it's more about a gas or a fee. Whenever you want to do a transaction on blockchain, you have to pay a gas fee. So where is this gas or the fee is going to come out from? So that's coming out from the subscription model. So as a subscriber, you'll have to pay a small fee to use this one. You can use whatever model you want to do, like pay as you go model, a gold subscription, silver subscription, platinum subscription. So you'll have to pay an annual fee or a monthly fee, and then you subscribe to this model. And that like reward is actually going to be distributed between your validator and your submitter. And after one point, validator will not get anything because that's going to be automated. So all of your rewards are directly going to your submitter. Takeaways. So we have seen the challenges with the traditional CTI model, and we have seen how a blockchain-based CTI approach is going to address some of those challenges, not all of them. Enhancing quality and authenticity of Intel feeds. How are you going to make sure that the Intel has got some standards of quality? Automated CTI sharing. How are you going to automate the process? And how are you going to make sure that the quality assurance is also there while automating that? Sharing Intel while preserving privacy. Yeah. So this is something we use zero knowledge proof. When you submit Intel information or an IoT information, you do not want to disclose the entire context, how you got it, what you did. Maybe you have your own POC, maybe you have your own research. You do not want to submit that. So that's where zero knowledge proof kicks in. You just have to submit that IOC, and via using zero knowledge proof, that can be validated by a validator without actually looking at your content. So your POC or your tool or your research stays with you, only the IOCs go into the chain. Ease of adoption and integration. Blockchain based model, and this is pretty much a dApp, so you can connect it to your SIEM solutions. Like if you have Splunk, you have ELK, then easy to integrate, or you want to integrate directly into your CTI tools like MISP, yeah, easy to integrate into that. Yeah, I'll take some questions now. Yep, sure.
I assume this is the layer 2 thing.
Later.
But through Ethereum?
We can do with Ethereum. We can do this with the chain. Want to select, it's going to be your call, but then Ethereum based chains are like easy for this one. You can use Avalanche. We actually used Avalanche for this one, but then again, it's your call where you want to deploy that. Any other questions? Yeah, please.
Can you go to that diagram?
Sure. Yeah, sure.
So in your consensus, you are using the green, right? And
Yeah. Yeah.
DH down with the other customers. Might not be like there might be compromised information. So how will you take a this one? And the second one is that your validator will get the reward, right? From proof of work, we have seen that the miner who solved the hash get the reward, and proof of stake we saw that the high value stacker get the reward. So how about here? Who will get the reward? As you said, that's to be debated among the validators, but it will be fair to other like I have more resources, I have used my more time on this one. So will it be fair for everyone if I speak equally up to everyone? So that is.
Yeah. So your first question was like blockchain is a decentralized app, and there is always this problem of if I have the majority, I can manipulate the data results. Like I have 60% majority, I can make whatever results I want. I have my friends submitting IOCs, and I'll make a group of my own validators, and they'll actually validate all of those IOCs. Rewards going to my friend. But then the validators who are being selected is always changing, and then it's always making sure that you select validators from the clusters which are having high reputation, and also making sure that even just to make sure it's fair, you also give one or two validators from the lowest clusters with a reputation on one chance, and then slowly you build that reputation in. So it's more like the reputation building thing. It's not like you just want to make a group and you are able to make that group. It's more like the machine deciding which is going to be the group, which is suppose for every different intel coming in, the validator group is going to be different. It's not going to be the same set of validators again and again. It's always going to be randomized, and I'll always make sure that out of 10, two of the validators are coming in from the cluster which is having a less reputation, so ensuring that the fairness is there. And your second question, how are the rewards going to be distributed? The rewards are for validators. It's going to be like the most reputed validator in that pool of validators. Suppose I have 10 validators, and the two of the validators are having a really good reputation. So the validator having the highest reputation will always get a slightly higher reward than the validator having a less reputation. But then again, since the validators are always rotated, it's going to be more or less fair. But then again, you cannot give 100% what you can say fair system in a blockchain, decentralized, right? So always there is some chance of that chain being manipulated here or there. I think that makes sense somewhat. Any more questions? Yeah.
Other than immutability, I really don't see any benefit to having this on the blockchain other than centralized data center. Something I missed?
Yeah, like one is like incentives, how like for providing your Intel things, then ensuring quality. Immutability, definitely, yeah. Then quality, ensuring your quality. Like I don't accept any Intel, but only the Intels which satisfy my quality.
So with the validator selection process, it seems like before the automation happens, there's a bit of a scalability thing. So how do you think the gas fees would be enough to handle someone like trying to DOS the system by just keep submitting things?
Like I can keep on submitting. I really don't have a limitation on the number of IOCs that I submit. But then again, the gas fee thing, like in order to sustain this model, you need to have some sort of gas fee or funding to in order to start that. And after that, it's going to be like a distributed model. You get that from your consumer and pay to your subscriber. But then, yeah, you just have to make sure that you have enough gas fee to get started on this model. Yeah.
I'm just trying to understand about the validator. You mentioned decentralized, but I think it's what it seems validators will be selected centralized sort of manner, and then they're like to who would select them? Like it seems like it's further centralized, and I'm just trying to avoid not some sort of sway for that selection process.
The selection process, initial selection is basically like you are like outside the chain, like you are reputed in your CTI Intel community, you just get selected. But once you get selected, you have a pool of selectors, like 100 selectors. And for each IOC, only 10 of them are going to be selected. So the ones are going to be the reputed ones, and also a random selection.
So when you say you select, like actual you and organization will not select their
No. Yeah, yeah.
And then certain number of so what is the method of activity? So in the mining, you see that people just open the machines and do the mining, right?
Yeah.
And sometimes either they might not be available. But what will happen here if the majority half of them are not available.
Just go for another iteration, select another round of validators because you are selecting out of a pool randomly. Not necessary that all your selected guys are available. So you just go another iteration and select other guys. Yeah, waiting time. Yeah, like you, if you are selected as a validator and you have X amount of time to validate or submit your evaluation, if you are not submitting that, second iteration, someone else is going to be selected. That's something you'll have to like adjust according to how your model is scaled, how many IOCs are coming in, and how many validators you have. That's all, guys. Thank you.